In this section we're going to cover electron configuration. On the screen we can see the diagram that we looked at previously, where we've got the first, the second, the third and the fourth shells, and it would be sensible to assume that we move from the first to the second to the third to the fourth, and this is partly true, and that we go from S, and we've got S and P, SPD, SPDF. So we may assume that this will be the order of filling in an atom, but this is not the case. So at the top of the screen you'll see the order in which we will fill the electrons up, starting from 1s and moving out. And so we're going to move from the 1s to the 2s, to the 2p, to the 3s, to the 3p. So all of that is as we'd expect, but then the 4s is filled before the 3d. To move even further through the shells of an atom, a good way of remembering it is to set the shells and the subshells out as you can see there, so as a sort of something of a pyramid. And then if we start in the top, so we go from the 1s to the 2s, and then just keep moving down like so, so from 2p to 3s, 3p, and then this is where it changes as we'd expect, so we move to the 4s, then to the 3d, to the 4p and the 5s, 4d, 5p, 6s, and so on. So in terms of moving away from the nucleus, so if the nucleus is down here, so as we increase in terms of energy, so we're going from 1s to 2s, to 2p, to 3s, to 3p, but now the 4s is slightly lower in energy than the 3d, and then we're into the 4p. In terms of the subshells and the periodic table, one thing that you might have noticed, there's a bit of a pattern going on. So an S subshell holds 2 electrons, the P we know holds 6, D 10, and F 14. If you have a look at the periodic table, so you can see I've drawn a rough image of the periodic table there, and I've broken it up into blocks. So the block on the left hand side, which is the group 1 and 2 metals, is 2 elements across. The block on the right hand side is 6 elements across. The transition metals 10, and then down at the bottom we have the lanthanides and actinides 14. So the number of electrons matches the number of elements in those particular blocks. So what's our electron configuration going to look like with this new system then? Well, take an example of oxygen. So oxygen has 8 electrons, atomic number 8, and we start filling from the 1s. So first electron goes in there, and then we'll fill the 1s subshell. We can see that the electrons with 1 spin up, 1 spin down, so that's the first energy level. It's the S subshell, and there are 2 electrons in there. Next we move to the second shell, and it's the S subshell. Again, 1 electron, second electron, and now the 2s subshell is filled, so that's the second energy level, s subshell, 2 electrons. So that's 4 electrons in total. We have 8 electrons, so that's 4 more electrons for oxygen. So we now move to the 2p subshell, and we'll fill it up as so. So each electron, so there's 3 electrons, so the electrons will want to move into their own orbital. Once we have 3, then the 4th orbital will then pair up, which is second energy level, now the p subshell, and there are 4 electrons in there. So for oxygen, how would we write the electron configuration? Well, we'll just put these all together. So it's 1s2, and then it was 2s2 and 2p4. This looks very different to how we might have written it at GCSE, although if we look at the numbers, then in the first energy level there are 2 electrons, and in the second shell we have 6 electrons. Oxygen's outer electrons are in the 2p subshell, and if we go back to our image of the periodic table, then we'll find that oxygen lies in the p block. Let's do the same, but now for silicon, 14 electrons. So that's 1s2, 2s2. We can fill the 2p subshell. So that's 2p6, that's 10 electrons that we've used so far. So 4 more remaining. We can fill the 3s2. So that's 12 electrons, 2 remaining. We're moving to the 3p subshell. 1 there, 1 there. So 3p2. In a previous life, we'd have probably said that the electron arrangement for silicon would be 2, 8, 4. Hopefully we can see there's the 2, there's the 8, and there's the 4.